Hello guys, in this video I would like to demonstrate photo live stacking in RAW and JPEG. The telephone I have here is a Huawei P60 Pro attached to a telescope, and you see a small star. But what I want to shoot here is M57, the ring nebula in constellation Lyra, which is a well-known object. And before I start live stacking, I'll show you the settings. Here I have a delay of 10 seconds. And the most important things are here at the bottom, photo live stacking. I'm using the algorithm average, and the tracking mode is tracked, or I can go to don't know. I can go to untracked. But I have a telescope and a telescope mode, so it's tracked. DeepSkyCamera Pro can handle tracked and untracked images, so this works. We have here a question: do you have some objects in foreground? Because it's a telescope. No, I don't have objects in foreground. Houses, trees, etc. And how do you take the images with is the next question. I take it with a telescope, and here associate to the telescope question is the eyepiece question, and I have a 100 degrees eyepiece. The camera sensor is fully illuminated. So when you have a smartphone only, you can do this, and I go back to telescope. So at the bottom are some information: analyze and realign frames. That make really sense in live stacking. Show stacked result after each image makes also sense, as well as show information and log information. That's good for bug fixing or chasing an error. And at least we have save each original frame if you want to stack with another stacking program. Save each rejected frame in case frames are rejected because they are bad. They are also saved to disk, and you can analyze later. But now I want to start live stacking. Here I show you the settings here. That's photo live stacking is activated. We have RAW, 30 seconds, ISO 800, ready, set, go. And now we are starting live stacking. It takes a couple of seconds. I have a delay of 10 seconds, and then we take 30 seconds each image. That's very good and totally enough for this object. The eyepiece I have here is a 7mm APM lens eyepiece, 100 degrees. That's a very good eyepiece. I love it, as well as the other APM lens eyepieces. So let's wait a couple of seconds, and then we will see the first image here. You don't see any progress yet. Please be patient. That's always the same. You must be patient. And here we have the first image. Please pay attention to a couple of things. First, you see the object M57 in the center, and we have some information at the top. The exposure time, total integration time, processing time, 3 seconds. The number of stars, and diff X, diff Y, and the rotation angle. These are very interesting information, but you can disable these information. Now we have the second frame, and when you take a look into the dark sky, into the background, it was noisy in the first image, and now it's getting better with the second image because it's average stacking algorithm. Pay attention also to processing time of a RAW file. That's 2 seconds here on the Huawei P60 Pro, and that's very good. JPEG is much more faster, but the problem is the quality. So yeah, it's now getting better. You see also the star in the center of the nebula. And let's go ahead. So when I push stop, the stacked result is saved to internal memory. That's a TIFF file. You must process the TIFF file. That's normal with every other stacking software like DeepSkyCamera, Zreal, PixInsight, or AstroPixel processor, Sequator, of course. And you must do the same with the images here. There is no auto post processing, no automatic post processing of the TIFF file. You must do it with your own software, or you must do it on your own. So that's pretty good. And I will show you the stacked result when we are ready. So let's give it a try. This is, now we have 5 images. So when I stop this session, you see the stacked image is saved to DSIM. So I go here to Photo Live Stacking, and here you have the images, and of course here is the TIFF file. I can zoom in, and of course you can see the star in the center, a little bit of colors, and the next thing is to post-process. I did the same thing a little bit earlier, but look at this, what's happening here. I think it's an airplane, and that looks pretty nice. So if you want to do JPEG live stacking, on some phones RAW is not available, you can do the same, switch to JPEG, and that's it. Now we start, and it's very similar to RAW live stacking, but it's faster because JPEG files are smaller than the big DNG RAW files. So let's wait until we have the first image. It takes 30 seconds and 1 or 2 seconds for post-processing, and that's it. So here we have the first image. Yeah, it looks good. So it's JPEG only, and every JPEG image is now stacked. As you can see in the information at the top, processing time is 1 second. It's much more faster than RAW. That's the case on every phone. But there are phones where RAW live stacking is very slow because of the system on a chip set. Especially the Unisoc and MediaTek are very slow. The Snapdragon are really good and really fast for our purposes. So this is also a good result. You can see the star in the center. So let's give it a try for a couple of images, and then we stop. So you see the pixel shift in X-axis and Y-axis, and the rotation angle. I have a telescope mount here, but it's not properly aligned. That's why we have a shift in X and Y axis and rotation angle. If the telescope mount is really good aligned, so you don't have a huge shift in both axes and you don't have a rotation angle. So now we have 5 frames. I stop here. So image is saved to DSIM, and here we are. So here you see the JPEG result file, looks also pretty nice. And here we have the star in the center, and that's it. For a user with a phone which does not allow 30 seconds, maybe 5 seconds or 8 seconds, like on the Fairphone 5, you can use a different setting. It's the add stacking algorithm. Add means every pixel is added, and the image gets light very quick, but that's very good for phones with limited shutter speeds. So I'll leave it as it is, and now let's go. So we have a delay of 10 seconds again. And let's check out the 8 seconds exposure time. So let's wait until we have the first image. And remember, it's RAW stacking. It takes a little bit longer than JPEG stacking. So here we are, the first image. We see M57. And now comes the second image. You see it's getting lighter because of adding the pixel. Now let's wait for 4 or 5 images. So it's a good thing for all the users with limited shutter speeds. If you have a phone with 30 or 60 or 120 seconds shutter speed, it's better to use average algorithm and 30, 60 or 120 seconds shutter speed instead of very fast shutter speeds and add algorithm. But this is also a good result. Now we have 5 images, each image 8 seconds. And here comes the next one. And now I stop the session and let's check out the TIFF file, the result. Here we have the TIFF file. And yeah, you can see the object here. You see some hot pixels here. To get rid of hot pixels, you must take dark frames, bias frames, and regarding vignetting, you must take flat frames. But this is a problem for live stacking. So we can do the same with JPEG as well. And when you do JPEG live stacking, there's a good thing that the hot pixels are removed. I have added some specific algorithms for removing hot pixels and noise reduction. So the image should look very similar, like raw stacking, but with less hot pixel. So here we can see that M57 comes up. Now we have 4 images, 32 seconds integration time, and so we take the next image and then I stop it. So now I stop. Let's check the images. So here you see less hot pixels. So that's a good result. And as you can see here, you have all the single frames, and you can take a look at the single frames if you want. Here, this is a single frame, noisy and hot pixels. And this is the stacked result, which looks much more better. Same with JPEG, very dark. And here we have the stacked result. So that's it, friends. Hope you like it.